Have you ever had one of those moments late at night where you see something that just doesn't seem possible?
Something that kind of breaks the rules of what you expect to see.
Exactly. Like being outside and it's dark, the sky is black, and you see a rainbow, but it's completely white.
Well, that very experience, that silvery arc in the dark, is at the heart of the deep dive you've brought us today.
It is. Our source material, this great dialogue between Ahmad and Sarah, confirms this thing is real. It's called a moonbow.
Or, as the source beautifully puts it, al-Quaz al-Kamari.
Oh.
And it really does feel like something out of a myth or a legend.
I love that name, Alquaz Alkamari. The lunar arch,
Oh.
it captures that feeling Ahmad described,
Yeah.
seeing it and thinking it was from another world.
Right. So our mission for this deep dive is to unpack that magic.
Demystify it.
Exactly. We're going to get into the physics, the very specific atmospheric conditions that have to line up perfectly. But I think the main goal is to solve that central riddle.
Why it's colorless.
Why a rainbow, an event defined by color, appears so strikingly white.
Okay, so let's start with the absolute basics. Let's just confirm for everyone listening that what Ahmad saw was 100% real. Not a trickle of light, not an illusion.
Oh, it's entirely real. And functionally, a moonbow is. Well, it's the exact same thing as a daytime rainbow.
The same mechanism.
The exact same. It needs light refracting or bending through water droplets in the air. That's the core principle. The light hits the water, slows down, splits into its different colors.
And if you're standing in just the right spot, that arc of color gets reflected back to your eye.
Yep. The only difference here, the key distinction, is the light source. It's not the sun, it's the moon.
So if the process is identical, then that splitting of light into a spectrum that's still happening inside every single water droplet.
It is.
But the descriptions, like the one from our source, are all about a pale or semi-white look.
Hmm.
So why don't we see a faint rainbow? Why white?
And that's the crux of it. This is where it gets really interesting because the answer isn't just about physics. It's about biology.
Our eyes.
Our eyes. The reason it appears colorless is because of a fundamental limitation in how the human eye processes color when the light is extremely weak.
Walk us through that. What happens inside our eyes when it gets that dark?
So our retinas have two main types of photoreceptors. You've got cones and you've got rods.
Cones handle bright light and color, right? Reds, greens, blues.
Exactly. And the rods are for low light. They're way more sensitive, but they have one fatal flaw.
They can't see color.
They cannot distinguish color at all. They're basically our night vision sensors, brilliant at detecting movement and shades of gray, but completely colorblind.
So in the deep dark, our eyes switch over from using the cones to relying almost entirely on the rods.
That's it. So your brain is getting a signal that says, hey, there's a bright arc of light over there. But it's not getting any of the color data to go with it.
And it just defaults to perceiving it as white or silvery.
Achromatic is the technical term. Yeah, it's our own biology filtering the color out.
And the source gives us that staggering number for why the light is so weak in the first place.
It does. Get this. Moonlight is about 1/400,000th times weaker than direct sunlight.
1/400,000. But that number is just, it's hard to even comprehend.
It's an enormous gap. The light intensity is just far too low to trigger a response from those color-detecting cone cells. It doesn't matter how perfectly the light is split by the rain.
So wait, does that mean the colors aren't actually there? Or are they there but we just can't see them?
That is a fantastic question. The colors are objectively there. They exist.
Okay.
And we can prove it. If you take a camera and do a long exposure photograph of a moonbow, leave the shutter open for 20 or 30 seconds.
The colors will show up in the picture.
They absolutely will. The camera sensor can gather up all that weak light over time in a way our eyes just can't. It reveals the reds and greens and blues that were there all along.
Wow. So it's subjectively invisible to us, but objectively real. Okay, let's pivot a bit. Let's talk about the rarity. Ahmad called it an historical astronomical coincidence. Why is it so hard to see one?
Because it requires this perfect storm of three very specific, very unforgiving conditions. If even one of them is slightly off, the whole thing is a no-go.
The impossible checklist. What's condition number 1?
Condition 1 is the light source itself. The moon has to be full, or at least very, very close to full, what the source calls albedo.
To get the maximum amount of light possible.
You need every last photon you can get, so that right away limits your chances to just a few nights a month.
Of a tough start. Okay, condition 2, the atmosphere.
Condition 2 is the water. You need light rain or even just a fine mist. But, and this is critical, it has to be falling in the part of the sky opposite the moon.
Just like a normal rainbow, the sun has to be behind you.
The geometry is the same. The moon has to be behind you, and it also needs to be pretty low in the sky, less than about 42 degrees up from the horizon.
Which is tricky because the kind of heavy clouds that bring rain would usually just block the full moon completely.
It's a very fine line. You need that isolated shower with clear skies behind you where the moon is. It's a very rare weather pattern in most places.
Okay, so that leads us to the final nail in the coffin, right? Condition 3.
Condition 3 is darkness. Absolute, total darkness.
No light pollution.
None. The slightest glow from a city, streetlights, even a distant town on the horizon. It can be enough to completely wash out that incredibly faint light from the moonbow.
So you need a full moon, you need rain falling opposite the moon at just the right angle, and you need to be in the middle of nowhere.
That's the trifecta. It's an amazing statistical hurdle to clear.
It's a wonder anyone ever sees one at all.
It really is.
So with all that in mind, are there any, I guess, hot spots in the world? Places where these conditions line up more often?
Yes, there are. While they're still rare everywhere, some places have a bit of a natural advantage. The source specifically points out two.
Where are they?
Near large waterfalls, particularly in Hawaii, and also in parts of Zambia.
Waterfalls. That makes perfect sense.
It does, right? It's all about the mist.
You're taking the most unpredictable part of the equation, the random rain shower, and replacing it with a constant 24/7 supply of water droplets in the air.
A continuous, predictable supply of mist. It's the perfect medium. So instead of waiting for the weather to cooperate, you just have to worry about the lunar phase and the darkness.
The odds get a little better.
A little. You still need that full moon, and you still need to be far away from any city lights. It's still an event. It's beautiful because it's so fleeting.
And then, just when you think we've reached peak rarity with a single moonbow, the source mentions the double moonbow.
Ah, yes. The Quaz Kamari Muzdawaj.
That just sounds like a myth.
It's the stuff of genuine legend. It works on the exact same principle as a daytime double rainbow. It's caused by light reflecting twice inside the water droplets.
And every reflection loses light.
A lot of light. So if the first moonbow is already fighting that 1 in 400,000 battle for brightness, the second arc is, well, it's almost impossibly faint.
You would need literally perfect conditions. Flawless.
You would. Standing by one of those Hawaiian waterfalls on the night of the full moon, with not a single cloud in the sky and the mist hanging just right, it would take incredible patience and a whole lot of luck.
So let's bring this all together for you listening at home. What have we learned here? That beautiful, ghostly white arc you might see at night. It's real. It's a moonbow.
And its lack of color isn't a mystery of the cosmos, but a fascinating trick of our own biology. It's your eyes shifting from their color-detecting cone cells to their light-detecting rod cells.
And we know that seeing one is a true astronomical coincidence. You need those three things all at once.
A full moon, rain or mist in the opposite direction, and a sky that is absolutely pitch black. If you've ever seen one, you should really appreciate how lucky you were.
Which brings us to our final thought. Now that you know exactly what to look for, the full moon, a waterfall, total darkness. Maybe this is a bit of an inspiration.
Knowing the science behind the magic gives you a real shot at seeing it for yourself. The source hints at the kind of dedication it takes to capture one.
And now that you know about the Quaz Kamari Muzdawaj, the double moonbow, maybe you'll be the one to spot that faint, legendary second arc.
We wish you clear skies and very deep darkness.